ये हुआ कि उधर दिखाई देगा तुझे? आजा गो लाइव पे अभी।
ये सर ऐसे रखता हूँ विंडो फिर, है ना?
हाँ, अभी ये देख, सुन मेरी बात। अब तेरा यहाँ तक आ गया ना, यानी क्या है,
हाँ
अभी ये लोगों को है ना कब दिखाई देगा, जब तू गो लाइव के बटन को क्लिक करेगा। गो लाइव
राइट
के
सर,
बटन को कब क्लिक करना तू? जब प्रोग्राम 4:28 को कर देना।
चलेगा चलेगा।
ओके।
सर ये पूछना था कि फिर आप पीपीटी आपकी इधर से रन करते क्या सर? यानी क्या फिर मैं इधर से करूँ विंडो का? ठीक है सर, चलो थोड़ा सा स्विचिंग दिखेगा, चलेगा ना?
नहीं 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 नहीं, तू सुन
हाँ
मेरी बात।
हाँ।
पीपीटी मेरे को भेज दे, कोई प्रॉब्लम नहीं।
पीपीटी भेजू क्या आपको?
सुन ना, मैं क्या बोल रहा था राजू।
हाँ।
तुझे एक्चुअली ये पता है क्या, तू जब अभी तू यहाँ पर आ, किधर, जूम पर आ, तो
आया सर।
जूम पे पीपीटी रन कर। फर्स्ट
ऐसे भी
पीपीटी।
जब, हाँ जम जाएगा सर, सिर्फ थोड़ा सा
नहीं
स्विचिंग।
नहीं,
हाँ।
अरे तेरे को नया चीज सिखाता ना रे आज, तू जूम पे
ओके
रन
ओके
कर।
ठीक। हाँ हाँ।
रन
हाँ किया
किया
सर,
क्या?
रन किया किया।
अभी तू क्या कर, इधर पॉज का दिख रहा होगा देखो, पॉज का, शेयर स्क्रीन के बाजू में पॉज वाला।
हाँ है सर।
वो पॉज किया ना, अब तू क्या कर, पता है क्या? नहीं, फिर से पीछे आ, पीछे और पॉज कर। पॉज किया?
हाँ। यस सर।
किया क्या?
हाँ
अभी
किया।
तू इसको पीपीटी जो है ना, इसको
मिनिमाइज
ये
करके।
करके और गो लाइव के इधर जाके, हाँ तू आराम से जा सकता है ना।
ठीक है, और
अभी
वो
मेरे को ऐसे के ऐसे ही दिख रहा है।
हाँ
हाँ,
हाँ
फिर प्रोग्राम स्टार्ट होगा ना, फिर
हाँ
प्रोग्राम स्टार्ट होगा तो फिर से क्या कर देते तू, इसको ऑन कर लेना, है ना।
हाँ। एक बार ये गो लाइव कर दिया कि मैं फिर डायरेक्ट वहां पे आता हूँ सर वापस, अपने इस पे।
फिर से यहाँ पे आके और इसको क्या कर देना, पॉज हटा देना।
ठीक है सर, ठीक है।
ओके, उसको डन कर
डन।
देना। ठीक है, समझ में आया तेरे को?
ओके सर।
अभी लोग आ रहे तो मैं एडमिट करूँ उनको?
हाँ सर।
मैं गिरीश पिंपळे सर को एडमिट कर रहा हूँ।
यस सर। मैं आपको होस्ट बना दूं क्या सर?
हाँ नहीं, को होस्ट हूँ ना मैं। उन्होंने फोटो
ओके।
भेजा है, मैं भेज रहा
यस सर।
हूँ। सर को लिया है मैंने, ऐड किया है। वेलकम सर, पिंपळे सर वेलकम।
वेलकम। ओके।
भंडारी सर, चेक योर व्हाट्सएप, मैंने सर का फोटोग्राफ भेजा है। तो मुझे आपके इस पर से ना लॉगिन करने दो, आपका ये दो ना, आपका मोबाइल दो।
मोबाइल का ट्रकीजित मारो बीच में।
इधर एक
मेरे को हॉटस्पॉट ऑन।
सर आपका म्यूट कीजिए अभी सर।
हाँ।
Good evening, everyone.
Good evening, sir.
Good evening, sir.
Good evening. Good evening. So excited. So excited. Yes. Yeah. So how many participants total today?
Bhandari sir, you can go
Yeah,
live.
great. Great. Yeah, great.
Puranik sir, please mute yourself.
Yeah. Yeah, I'll do that. Yes. Yes.
Okay.
भंडारी सर गो लाइव हो चुका है, आप मेन स्क्रीन पे आइए. भंडारी सर, make me co-host.
Done, sir.
Karode sir, can we start the program? It's 4:30.
Yeah, just I think let's wait for a couple of minutes.
Okay sir.
तिकडे युट्यूबला किती लोक आलेत कळतं का तुला?
Yes sir, कळतं ना.
किती आलेत अप्रॉक्सिमेटली?
साधारणतः 45 आहेत सर आता.
Good. So another 2-3 minutes we will start.
Okay sir. Bhandari sir, please mute everyone. Karode sir, can we start the program?
Yes, we should start.
Okay sir. Hello everyone.
I welcome you all on behalf of CSI Nashik chapter for this wonderful webinar on Tour of the Universe. Today, we have with us all well-known personalities, and one of them who is actually acting as resource person today, Dr. Girish sir, who is gonna take us for the tour of this universe. I welcome you, sir, and I welcome all the dignitaries of CSI Nashik chapter, especially Karode sir, who is CSI fellow member, our chairman, Nitin Mahajan sir. I'm acting as Vice Chairman in CSI Nashik chapter, as well as Professor and Head in Department of Computer Engineering, SNJB's Letso KB Jain College of Engineering, Chandwad. I welcome all the office bearer of CSI Nashik chapter, all the committee members of CSI Nashik chapter, all the past chairman, patron members of CSI Nashik chapter. I also welcome, because this particular program is in association with SNJB's KB Jain College of Engineering accredited wing, student accredited wing. So I welcome our principal, Dr. MD Kokate sir, who is actually one of the vibrant principal of our college. And I welcome all the participants, those who are actually participated all pan India. So without wasting much of time, I request Bandari sir to please show the next slide. I just wanted to show everyone the committee, all the committee members, managing committee members of 2020, 21, 22, all the managing members as well as nomination committee members. I request Puranik sir to please introduce our today's resource person, Dr. Girish Pimpe sir.
Good evening to all. I am Jai Krishna Puranik, life member of Computer Society of India. I am honored to introduce today's speaker, Dr. Girish Pimple, for his lecture on the tour of the universe. Dr. Pimple has a very bright educational career. He has done MPhil in physics and PhD in year 2012. He has an experience of 37 years in teaching, and the subject which is at his heart is astronomy. For this subject, he got the guidance from the well-known scientist Dr. Ajit Kembhabe from IUCAA. Dr. Pimple has taken part in many national and international conferences, and he has presented his research papers on the subjects of astronomy. He has visited various places during solar eclipse. He is fully devoted to educating the general public on the subject of astronomy. He has published 4 different books in Marathi, which includes Kutuhal Khagolacha, Ved Khagolacha, Vijnanacha Antarangat, Katha Havar Durbinichi. We are very happy to have Dr. Pimple with us, who would be talking to us on his subject, which is most liked by him, the tour of the universe. We welcome Dr. Pimple and we request him on behalf of Computer Society of India and the associated organizations to make his presentation, which I am confident would be very lively and liked by each and everyone present here. Thank you, CSI, for giving me this opportunity. Thank you, Dr. Girish Pimple, for your sparing time and talking to us very soon. Thanks again.
Now I request, thank you so much, Puranik sir. Now I request Dr. Girish Pimpe sir to please take over. I request Bhandari sir to to please stop our screen sharing so that sir can able to share his screen. Your screen is visible, sir. Now you can run your presentation. Yes, sir. You can run the presentation. It is now visible. Sir, your presentation is visible. You can directly run it. Sir, you have to simply run your presentation so that it will be ready.
Yeah. Now, can you hear me, please? Can you hear me?
Yes, sir.
Yes,
Your
sir.
voice is little bit down.
Okay. Computer Society of Indiaचे चेअरमन महाजन सर, माननीय करोडे सर, जैन इंजिनिअरिंग कॉलेजचे प्राचार्य डॉक्टर कोकाटे सर, हा कार्यक्रम आयोजित करण्यासाठी त्यांनी खूप मेहनत घेतली आहे ते संघवी सर आणि जयकृष्ण प्राणी आणि मित्रांनो.
ओके ना सर.
Hello.
येस सर, येस सर. ओके.
आता माझा आवाज येतोय ना?
सर, कमी येतोय खूप.
What should I do then? पण इथे तो फुल आहे व्हॉल्यूम. व्हॉल्यूम फुल आहे.
ओके सर, ओके नाव.
येतोय का आता? आता
येस सर, येस सर.
आता
येतोय.
नीट येतोय? नीट येतोय आता? हॅलो.
येस सर, क्लिअर सर, क्लिअर.
Would you like
सुरुवातीलाच
to make it full screen? View full screen so that
Yeah.
side
Yeah.
slides are not seen. Yes, full
Okay.
screen. Yeah,
Okay.
great.
Okay. सुरुवातीलाच मी आपल्या सगळ्यांचे मनापासून आभार मानतो, कारण आज गणेश चतुर्थी सारखा एक महत्वाचा सण असून सुद्धा तुम्ही या कार्यक्रमासाठी सगळेजण उपस्थित झालेले आहात आणि या कार्यक्रमाचं आयोजन केल्याबद्दल मी कम्प्युटर सोसायटी ऑफ इंडिया आणि जैन कॉलेज ऑफ इंजिनिअरिंग यांचं पण मनापासून आभार मानतो. आपण गेल्या पाच एक महिन्यांपासून कुठल्याही टूरला जाऊ शकत नाहीये, परंतु युनिव्हर्सिटी टूर करायला मात्र आपल्याला काहीच हरकत नाहीये. त्याच्यासाठी आपल्याला कुठल्याही पासपोर्ट व्हिसाची गरज नाही, परंतु त्याशिवाय आपल्याला ई पासची सुद्धा गरज नाही. तर अशा या टूरवरती आता आपण जाणार आहोत. लेट मी टेल यू दॅट दिस इज गोइंग टू बी अ पॉप्युलर लेवल लेक्चर, सो इट इज meant for amateurs and not for expert in the field. Now, if I ask you whether you have seen the beauty of night sky, I'm sure your answer will be yes. Then clearly a question comes to our mind as to how many stars are there in the in the sky? An obvious answer will be infinite number. But scientists are not satisfied with such answers. So they try to make an estimation of the number of stars in the sky. Now, if the sky conditions are favorable, now what I mean by favorable sky condition, it should be new moon night. It should not be rainy season, so no cloud, no dust, no smoke. The place of observation is away from the city and preferably on a hilltop. And most important, it should have a good eyesight. So when such is the case, then a good human eye can see nearly 8,000 stars. If you use telescope, then you can see more number of stars. So likewise, if we go on increasing the size of the telescope, naturally the number of stars which we can observe, the number also goes on increasing. So I will give you one estimate that if the stars in our galaxy, only in our galaxy, that is the Milky Way, suppose these stars are plucked and are distributed among all the people who are on the earth, we know that the number is more than 7 billion, then each one of us is going to get nearly 35 stars. That is the number, approximate number of stars and of course other objects in our own galaxy, and there are billions of such galaxies. So one galaxy, what is a galaxy? Galaxy is a huge system. It is a huge system of various objects which are bound to each other by force of gravity. So there are billions of objects in our galaxy and there are billions of such galaxies. So let us have a tour of this universe. So let us start with our solar system. We know that there is only one star, that is the sun. Number of planets is 8. Mercury, then Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. These are the 8 planets in our solar system. Now let us see the sizes of these planets. The Earth is larger than Venus, Mercury, and Mars. What about other planets? As compared to the Earth, which looks like a ball here, Uranus and Neptune are quite bigger, Saturn still bigger, and Jupiter is the biggest planet in our solar system. In Marathi, we call Guru, or Jupiter, we call Guru. The word Guru has got 2 meanings. One which all of you know, that is a teacher, and second is big. So Guru itself means big. So perhaps our ancestors were aware of the fact that Jupiter is the largest planet in our solar system. Then if we compare the sizes of Jupiter and Sun, what do we observe? See, Jupiter is reduced to a ball, and Earth is hardly visible over here, just like a small point, just like a small pixel. So does it mean that Sun is a very big star in our universe? Let us compare that. The Sun is looking like a marble. So compared to Sun, there is another star called as Sirius. But Sirius is also not the biggest. Then another star, Pollux. Then Arcturus. Is Arcturus the biggest? So again, the answer is no. Arcturus is here, again like a marble. So there are still bigger and bigger stars like Regal, Aldebaran, Betelgeuse, Antares, and so on. So our sun is an average star. It is an average star in this universe. Now, so far we have talked about sizes of various objects. Now let us talk in terms of distances so as to know how big the universe is. So Earth, circumference of the Earth is 40,000 kilometers. And the average distance between Moon and the Earth is 3,84,000 kilometers. Then distance between Sun and Earth. The answer is, the distance is nearly 15 crores of kilometers. And this is the solar system. Our solar system. Here we see the Sun, Mercury, Venus, Earth, Mars. In between Mars and Jupiter, there is a belt called as asteroid belt. About this we will talk in detail later on. Then comes Saturn, Uranus, and Neptune. So the Neptune is the farthest planet. Neptune is the farthest planet in our solar system. And the distance between the Sun and Neptune is nearly 450 crores of kilometers. So that is about the size of our solar system. Now let us go beyond solar system. So I was telling you about galaxy. It is a huge group, huge system of billions of objects. Name of our galaxy is Milky Way. In Marathi we call it as Akashaganga. And our solar system is a negligible part of the Milky Way. Just like a drop in ocean. So here is the photograph of the Earth. I hope you can see this minute dot over here. That is our Earth. It is described, rightly described as the pale blue dot. This photograph was taken by a spaceship called Voyager. And it was taken 30 years back. And the distance was 6 billion kilometers. So this photograph of the Earth was taken when Voyager 1 was leaving our solar system. And it was at a distance of 6 billion kilometers from the Earth. So in that dot, see whether we can see Nashik or India in that pale blue dot. So now let us go beyond our solar system. Now when we talk about the space, kilometers, this unit of distance is of no use. So we have to use term called as light year. So what is a light year? We know speed of light is 3 lakh kilometers per second. And 1 light year is the distance traveled by light in 1 year. Distance traveled by light in 1 year. So if we talk in terms of light years, then the nearest star, that is Proxima Centauri, nearest star Proxima Centauri, is at a distance of 4.25 light years from us. It means that light has taken so many years to reach Earth. The light has started 4.25 years ago from this star Proxima Centauri and is reaching us today. So what we observe in this particular star is 4.25 years old. So this is the photograph of our galaxy. That is the Milky Way. The photograph is taken when we are inside the galaxy, and therefore complete galaxy is not visible to us. In order to take photograph of the complete galaxy, we have to go outside which has not been possible so far. But suppose if we go outside of our galaxy and so if we go outside of our galaxy and observe how the galaxy will look like. So this is the bird's eye view of our Milky Way. It is a spiral type of structure. And this is a photograph of another galaxy named as Whirlpool galaxy, which is similar to our own galaxy. So if we measure the distance from one end of the galaxy to the other end, our Milky Way galaxy, then that distance is 1 lakh light years. It is 1 lakh light years. So if light starts from this point, then it will take 1 lakh years to travel to the other end of our galaxy. So that gives us an estimate of the diameter of Milky Way. Now this is also a similar galaxy, and this photograph is shown in order to explain where is our solar system in our galaxy. So this is the point where our solar system is situated, and the center of galaxy and this point, center of galaxy and this point, this distance is 30,000 light years. Okay, so our Milky Way, in our Milky Way galaxy, our solar system is a totally negligible part. Next, we have got what is called as local group of galaxies. So our galaxy is a part of this local group, and the diameter of that local group is indicated over here. That local group is part of a big cluster of galaxies. It is a big cluster of galaxies. That is called as supercluster. And many such superclusters are making the universe. So many such superclusters make the universe. And according to the present knowledge, the diameter of the universe is 93 billion light years. Of course, this is the present knowledge. This figure can change in future. So henceforth, I think we will use the word, two words, world and universe, with caution. Okay, when we say world, we are referring only to the earth. And when we say universe, we are talking about this entire universe, which I described to you. And I'm going to show you. So that such a big system is the universe. So we should not say Miss Universe contest. We should always say Miss World contest. So what is our address in this huge universe? So it is Earth, 3, the solar system. I have said 3 because ours is the third planet from the sun. Then the Milky Way, solar system, part of Milky Way. That is part of local group of galaxies, part of a supercluster of galaxies, and finally the universe. So now we are going to have a tour of such big universe. So this I have already told to you. Then the branch of science which studies universe is known as astronomy. In Marathi we call it as Khagol Shastra. Now this term astronomy is always confused with astrology, which means Phala Jyotish. So I have seen this confusion many times. That is why I'm highlighting it. So astronomy is a branch of modern science, while astrology is not at all a branch of science. So some terms you may find that are common in these two branches, but these two branches are totally different. How big is the universe? Leo Tolstoy, the Russian thinker, says it is as big as one's head. I need not explain the meaning of this term, this sentence. Okay. So this is some spaceship, space shuttle as it is called, which is used for the tour of the universe. So we are using this. So now we are in the space. See, once upon a time, spacewalk was existing in fiction. But nowadays, it has become a common event that is taking place. So this slide shows you International Space Station. Now this International Space Station is basically a laboratory which is in space, and it is going around the Earth, and one revolution around the Earth it completes in only 90 minutes. So in 90 minutes, it completes one revolution around the Earth. So in 24 hours, it completes 16 revolutions. So the astronauts which are sitting in this space station, they can see sunrise and sunset 16 times in 24 hours. 16 times in 24 hours. Now, some specific experiments, some spatial experiments are carried out in this observatory or say laboratory, and where we require extremely pure environment. So some medicines are made over there, some alloys are made over there, and some other experiments are performed in this particular space station, because that is the zero gravity environment. And this space station is about 400 kilometers above the Earth's surface. So how the Earth looks like? So this is the actual video clip which is taken by the space station. Now let us come to the sun. Now let me tell you that sun is a very huge sphere of hot gases, extremely hot gases. But the surface of that sphere is not a well-defined surface. So a lot of activities are going on the surface of the sun as well as in the interior part of the sun. Now here you observe what is called as a solar flare. Solar flare. But the gravity of the sun is so intense that these solar flares again return back to the sun. So what is this height of the solar flare? So this slide gives you some comparisons. This is the height of the solar flare, while this is the Earth. So we can see that the flares are reaching a height more than the diameter of the Earth. So if we go to the center of the sun, this is a computer animation. If we go to the center of the sun, we see fusion reaction taking place, where two hydrogen nuclei combine to form helium. So here we find that two nuclei combine and energy is given out. So this is the energy given out. So this is what we know as the solar energy. And it is because of this fusion reaction that we are alive on the Earth. So this fusion reaction is very important. At any given time, there are billions and billions of atoms combining in interior of the sun, and for that matter, in the interiors of all the stars. So this is the spectacular view of a total solar eclipse. Now this white portion is called as corona, and this is visible only during total solar eclipse. This is visible only during total solar eclipse, and therefore that is a great opportunity for scientists to study the sun. Now this is another very beautiful picture that we get at the time of total solar eclipse. This looks like diamond ring, and this is diamond, and this is a ring, and here these red spots are they look like beads. Bailey is the name of scientist. This particular situation is there existing only for a few seconds. It is so impressive that we cannot forget it for lifetime. Diamond ring and Bailey's beads. That is the spectacular effect that is observed at the time of total solar eclipse. This is the annular solar eclipse, which was there in the last year itself, this year also. Annular solar eclipse is a rare event, and therefore, whenever we have got opportunity, we should enjoy that particular event. So far, I have seen 6 total solar eclipses and 1 annular solar eclipse. Now let us come to the most beautiful object in the sky, that is moon. Now from distance it looks very attractive, but as this clip shows you, this is the actual clip. As this clip shows us, there are many craters on the surface of the moon, and there are black regions. These black regions, actually these are plateaus, various plateaus on the moon surface, and these are formed because of the volcano and the lava which has come out of volcano once upon a time. Now this is another very interesting photograph of the Earth, which is taken from the moon surface, and it was taken by Apollo spaceship. Now here I have said it is Earth rise on the moon. So here Earth is rising, it has come up further. Now one thing you must have noticed, that we don't see the entire Earth. We observe only say 75% of the Earth. So does it mean that there are phases of the Earth as seen from the moon? The answer is yes. The answer is yes. Also, I can tell you one very interesting fact about these phases. When this photograph was taken from the moon, I can tell you that there must be crescent of the moon on Earth. There must be crescent of the moon on Earth. That is, only 25% of the moon must be visible on the Earth. So when we see from the moon 75% of the Earth, and when we see the moon from the Earth 25%, it means that the phases are complementary. The phases are such that they are complementary. So when there is new moon on Earth, there is full Earth on moon, and vice versa. So that is why I have said that these phases are complementary. Now why it is like this, that you will find out. Also on the moon, the sky is dark. So you will say, what is great about this? It must be night time. But that is not the case. Sky on the moon is always dark. This is because of the fact that there is no atmosphere or very thin atmosphere is there on surrounding the moon. And therefore, the sky is always dark. So what we can see, on one side, sun is visible, and on the other side, stars are visible. So if you happen to visit moon in your lifetime, do observe this extraordinary phenomenon that sun and stars are visible at the same time. Okay, now to the first planet, that is Mercury. It is very close to the sun. There are many craters, and since it is very close to the sun, it is difficult to observe it. But we can observe it sometimes after sunset or before sunrise in the east and after sunset in the west. Next is Venus. Now, this is not the actual color of Venus, but a false color is given in order to highlight the density of clouds which are there surrounding the Venus. Now, these clouds are made up of largely carbon dioxide. And the property of carbon dioxide is that it reflects 80% of the sunlight. And that is why Venus looks so bright. And it looks so bright that we are tempted to call it as an evening star or morning star. But please remember that it is very much a planet. Now, one very interesting fact about Venus, I would like to tell you. And that fact is the day on Venus is longer than the year on Venus. Okay? The day on Venus is longer than the year on Venus. So there are many such miracles in one sense which are present in our solar system. Now this is an event called as transit of Venus on sun's disk. Let me play it once again. Transit of Venus on sun's disk. Then comes our home planet, that is Earth. Now there are many features of our planet. First is the distance of the Earth from the Sun. So the distance is such that, or I'll say that the distance is critical. It is not less, not more. Suppose the Earth were closer to the Sun. I have told you the distance. It is 15 crores of kilometers. Distance between Sun and Earth. But suppose the distance were shorter, then what would have happened? High temperature. And perhaps the life would not have been possible on the surface of Earth. If the distance would have been more than the present distance, then low temperature, and therefore again perhaps the life would not have been possible on the surface of Earth. Also, the Earth is surrounded by a thick blanket of atmosphere. So the harmful sun rays are filtered. Also, there is plenty of water. 70% of the surface is covered with water. Then there is magnetic field surrounding the Earth, so that charged particles do not reach the Earth's surface. So there are so many favorable conditions which nature has created, or if you say God has created, and because of that, the life on the Earth has become possible. So the birth and survival, both. This has been possible because of all these favorable conditions on the Earth. So we should regard ourselves very fortunate that we are living on this planet Earth. Then comes mass. Now, as soon as we talk of mass, we are reminded of the horoscopes and matching of horoscopes and so on. But let me tell you that Mars is a very beautiful planet. It looks so beautiful through the telescope that we are convinced that it will not trouble anybody in his married life or in his entire life. So this Mars is covered by iron oxide, which is reddish in color, and therefore Mars looks reddish. Is there water on Mars? Yes, but in frozen form, as you can see over here. Ice caps you can see. So there is water on Mars, but that is in frozen form. Is there life on Mars? Till today, the answer is no. So we don't have any evidence of life on Mars. But because of science fiction movies and novels, many people think that there must be somebody living on the Mars, but there is no evidence of such life on Mars. Then in between Mars and Jupiter, I told you that there is a belt of asteroids. So what is an asteroid? It is a huge rock of irregular shape. And there are thousands and thousands of such asteroids in that belt. Then comes Jupiter. It is the largest planet in our solar system, I have told you. Now the central part of Jupiter is solid, but the outer part is gaseous and the atmosphere is quite turbulent. So many cyclones are there in the atmosphere. For example, this red spot that you see over here, it was a mystery for scientists. For 300 years, scientists were studying what is this spot. And finally, it turned out that it is a big cyclone on the surrounding the Jupiter. There are many satellites to Jupiter, and this is one of them called as Ganymede. This was discovered by Galileo. So it is one of the Galilean satellites. So this is the beautiful picture that we can see through a telescope. This is Moon. This relatively large spot is Jupiter. Then can you see these two small dots over here and two more here? Those are the four satellites of Jupiter. And these are the Galilean satellites. Let me tell you that Jupiter and therefore its satellites are pretty away from us in crores of kilometers. And in spite of that fact, they are visible through a medium-sized telescope. So I have seen this many times. If we are lucky enough, we can see 5 satellites also. Then this is the Saturn. This photograph was taken by Hubble Space Telescope very recently on 4th July, when the distance of Saturn was 134 crores of kilometers from the Earth. And not only Saturn, but its satellites are also visible. Can you see this spot? A small dot over here, another small dot over here. These are 2 satellites of Saturn, and imagine that the photograph was taken from 134 crore kilometer distance. See the clarity of these rings. Also see the gap between these two rings. This black region is nothing but the gap between these rings. Actually, there are many rings to Saturn. Not only one, but many rings are there and they are well separated. So this photograph shows us that gap also. So this is the computer animation of the rings of Saturn. Then comes Uranus, then Neptune, last planet in our solar system. Then comets are also members of our solar system. So recently there was a comet, Neowise. So this Hale-Bopp comet was visiting the sun a few years back. Then this is the meteor. Now meteors are popularly but wrongly called as falling stars or shooting stars. Actually, a star cannot shoot like this or fall like this. So that description or that term is not correct. So meteors are simply some stones which are there in space, and when Earth is passing close to those stones, those are attracted towards the Earth. When they travel through the atmosphere, there is friction, they catch fire, and therefore we get a beam of light, momentary, transient beam of light. Now let us go beyond our solar system and let us go to stars. So when we observe through a telescope, a big telescope, in any region of the sky, almost all regions show us so many stars. Sky is full of stars, whichever direction you observe. Now in this slide, you find that there are different colors to the star. So what are these colors? What is the meaning or what is the significance of these colors? The color of a star tells us two important facts about that particular star. Color tells about temperature and about the age of the star. So for example, here you see red star. A red star means the temperature is lower, relatively lower, maybe say 4000 Kelvin, 5000 Kelvin, like that. And it is an old star or it is a dying star. But does it mean that stars die? Yes. There is a life cycle of stars. So I'll talk about that life cycle in the next slide. So red color, this star is a low temperature dying star. While some stars, for example, this is white color. So a white star is a young star, maybe a college going student. So it is a young star and the temperature is high. And some stars you will find, for example, this or this, these are yellow colored stars. So these are intermediate, both in respect of temperature and age. So what is the life cycle of a star? See, this region is called as nebula. Nebula. Stellar means related to star or of star. So nebula means it is a big cloud, very big cloud. So stars take birth from such cloud. So star has taken birth. Then suppose it has come to say nearly midpoint of its life. So it is yellowish in color. Our sun is yellowish in color, so it is at the midpoint of its lifespan. What is the lifespan of a star? The lifespan is in billions of years. Our sun is now 5 billion years old. Sun is 5 billion years old, and it is going to survive for another 5 billion years. So when the fuel inside the star is exhausted, then the dying process starts and it expands. And what is formed is called a red giant star. Then after that, there is death of that star, and three possibilities are there. First, either it will be converted into a very small star, high density star called as white dwarf, or a neutron star, or a black hole. So black hole is what? It is basically a dead star. This picture shows you a nebula called as bubble nebula. There are thousands of nebulas in the space. And see the distance. So the photograph is taken from this distance, and still we have got this much clarity. And this is another nebula called as butterfly nebula, and the distance is also mentioned over here. Then this is Eagle Nebula, 7,000 light years away. See, even though these objects are at such a large distance, see the details with which photographs are taken. So astrophotography is a very advanced branch of astronomy. This is some computer animation done of Eagle Nebula. So this slide shows us an artist view of a black hole. Artist view is shown over here because it is not possible to take direct photograph of the black hole, because as you can see, in this region the black hole is existing, and it is called as black because it is not allowing even light to escape. And that is why that region looks black, and hence the name black hole. But very recently, using some indirect method, first image of black hole was taken. Nearly 1 year back, that image was taken, and this black hole is existing at nearly 54 millions of light years away. So this is a very interesting photograph because this is the first image of any black hole. Then I told you about neutron star. So this is also a very interesting object in astronomy. So I have told you that either black hole or neutron star is formed, or white dwarfs are formed. White dwarfs are formed. So these are the three ways in which a star can die. Then these objects are called as pulsars. So what are these pulsars? These are the same, nothing but neutron stars. That is why I have shown this slide in continuation with neutron star. And these pulsars are sending pulses of radio waves in space, and that period is extremely regular, and therefore they are termed as clocks in space. This pulsar is rotating about its own axis very rapidly, and when one rotation is complete, it gives out a pulse. Now this is a photograph of many galaxies, rightly called as galaxy zoo. This photograph was taken by the Hubble Space Telescope. So you will find that there are different shapes and sizes of the galaxies. And mind you, that this one galaxy, one small region, is containing billions of objects. Not only stars, but planets, comets, then black holes, pulsars, neutron stars, white dwarf, and everything. So this each of these galaxies is containing billions and billions of objects. Then this shows us the photograph of our neighbor in this universe. And that neighbor is Andromeda Galaxy. Andromeda Galaxy. I have also indicated distance of this galaxy. So if this is the nearest galaxy, then you can imagine about the distances of other galaxies which are away from us. Now this is a very spectacular view in the sky. This is called as Pleiades, or in Marathi we call it as Krutika. This is an open star cluster. Open star cluster. There are two types of star clusters: closed structures, clusters, and open cluster. Then there are some objects called as quasars. These are the most distant objects in the universe and most bright objects in the universe. So a lot of research is going on about quasars. Now this is a telescope. This is called as the optical telescope. The usual telescope which we see and use is called as optical telescope because it is receiving only visible radiation. This is the telescope situated at Ayuka, Pune, and it is 16 inches, meaning that the diameter of the mirror which is situated is 16 inches. This is a totally computer controlled telescope. Nowadays, all big telescopes are computer controlled, or as we call them as smart telescopes. I was fortunate enough to use this telescope to carry out my research project in Ayuka. Then, this is the Hubble Space Telescope. So almost all photographs which you have seen in this program are taken by Hubble Space Telescope. Hubble is the name of scientist, Edwin Hubble, who has done pioneering work in astronomy. Now this telescope is at a height of nearly 570 kilometers. It is going around the Earth, and it was launched in space in 1990. So it has completed 30 years of its operation. Initially, it was thought that the lifespan is 15 years, but later on, some servicing was done of this telescope in space 4 times. And now, even after 30 years, Hubble telescope is giving us excellent views of the universe. The information which is sent by Hubble Space Telescope is so significant that now, as if astronomy is divided into two parts, that is pre-Hubble astronomy and post-Hubble astronomy. Then this is another telescope called as radio telescope, GMRT, Giant Meter Wave Radio Telescope. So this telescope is situated near Narayangam. Here only one dish antenna is shown. Its diameter is 45 meters, and there are 30 such antennas, 30 dish antennas are there. So that is the largest radio telescope in the world. So we should be proud that this was designed totally by Indian engineers and scientists. Now this is another telescope, or let us say observatory in space, that is called as Chandra X-ray Observatory. Chandra is name of an Indian scientist, Chandrasekhar Subramaniam, who was given Nobel Prize in Physics for his research in astronomy. Now, so far, the universe that we have seen.
Come.
Now let me tell you one amazing fact about this universe. The amazing fact is the observable universe using all electromagnetic waves. By electromagnetic waves, what we mean? Visible rays, radio waves, microwave, X-rays, infrared. So all these are electromagnetic waves. So by using these electromagnetic waves, the observable universe is only 4%. So what I have told you, that one galaxy containing billions of objects and there are billions of galaxies, this is only 4%. That is what scientists think. Then what about remaining 96%? So non-observable universe is 96%. And what is that? So in that, there is something called as dark energy, which is 72%, and dark matter, that is 24%. So this total gives us 96. Therefore, the universe about which we are talking is only 4%, and 96% is still not observed by the scientists. So what is that dark matter? Actually, much research is going on, but here you will find that some dark regions are there. Some dark regions are there. This is some supercluster. This is the actual photograph of that supercluster. So these dark regions must be dark matter. That is what scientists think. Also, in this another photograph, some ring is visible, dark ring is visible, and that is also made up of dark matter. So there are some big questions in cosmology. Cosmology is what? It is branch of astrophysics which deals with the birth of the universe, its structure, its evolution, and the probable end of the universe. So that comes under cosmology. So what are those big questions? Dark matter and dark energy. What are these two ideas? If dark matter is existing, what is the composition? Then gravitational waves. As you know, some 4 years back, gravitational waves were detected. And now research is going on about gravitational waves. Then understanding Big Bang. What is Big Bang? So it is believed that this universe came into existence from a point called as singularity, and there was a big explosion that is called as Big Bang, and since then the universe is expanding, and this took place about 13.82 billion years ago. So what happened immediately after Big Bang? That is a matter of query for most of the scientists. Then scientists are also thinking about the fate of the universe. What is going to happen? Will the universe expand forever? Or will there be end of the universe? If yes, how that end will be? So all these questions are addressed in cosmology. And the most important, or we say billion-dollar question is whether our universe is the only universe or there are other universes also. So whether universe or multiverse. That is also a very big question that scientists are researching upon. So now we are coming to the end of this program. Space, as we roughly say, that it is a region beyond the Earth's atmosphere. And therefore, for astronomy, sky becomes the lower limit. Sky becomes the lower limit. So I thank you all for participating in this webinar. I thank Computer Society of India and Sanwat College of Engineering, Jain College of Engineering, Sanwat. Thank you. Thank you very much.
Sir, there are some questions. I'm really thankful to you for the wonderful session. So before we go with the takeaway message of this session and vote of thanks, I would like to ask some questions from the participants. Can I ask you, sir?
Yeah. Go on.
Yeah. So Mr. Fikri Akbardi has asked the question, why NASA always gives us computer generated photo almost all?
See, it is not the case that always computer generated photos are there. Actual photographs are also given, but some photos are public photos, public pictures. For example, the photos which I have shown you. While some photos are reserved for their research, so perhaps they are not sharing those photographs.
Right, sir. Thank you. Sir, the next question was related to asked by Puranik, sir.
Yeah.
Can you please brief us regarding institutional which are doing research in astronomy in India?
Actually, there are many institutions. For example, the prime institution is Ayuka, that is Inter-University Center for Astronomy and Astrophysics in Pune. Then Tata Institute of Fundamental Research is there in Mumbai. Then Raman Research Institute is there in Bangalore. Then there is one more institution in Ahmedabad. Then in Nainipal, there is a big observatory and one more, the institution related to that observatory. So there are many institutions. Actually, I will require a separate lecture to tell about various institutions which are working in the field of astronomy in India.
Right, sir. Sir, there was thanks a lot, sir. There was question from Alka Chaudhary, madam. Is there is any live? There are so many members which are there on YouTube live. Almost 100 plus people are listening to you on YouTube live, and
Yeah.
I'm taking some questions from YouTube live.
Yeah.
So Alka Chaudhary, madam, have asked you one of the question: is there is any life existing on any other galaxy?
See, as far as our present knowledge is concerned, there is no life. But that does not mean that in future we will not get any, we will not discover any life on other planets or in other galaxies. But till today, the answer is no.
Okay, sir. Now the next question is from Pranav Mishra. Pranav Mishra, sir, why Pluto is not taken in our solar system?
See, Pluto was there in our solar system once upon a time, that is before 2006. But there were some objections raised about the status of Pluto. So there is an organization called as International Astronomical Union, which met and discussed this matter. A committee was set up actually, and then it was decided that the status of Pluto as planet should be withdrawn, and instead it should be called as a dwarf planet. So since then, Pluto is called as dwarf planet. There are some conditions or say criteria which are fixed by this International Astronomical Union, and Pluto does not satisfy those criteria.
Okay, sir. Mr. Vishal Gade also has asked one of the question. How two black hole, if they comes nearer, help to study gravitational waves predicted by Einstein?
Yes, when two black holes are coming closer, they actually they follow a spiral path, and finally they mix into each other, they merge into each other. And this motion is very violent, and the space around it, that is space time, as Einstein has said, that set in vibration, and those vibrations are received on the earth in the form of gravitational waves. And whatever, see, for what happened in case of 2015, which we detected those gravitational waves, two black holes merged into each other, but the resultant black hole which was formed was having smaller mass as compared to the addition of masses of the two black holes. So that difference appeared in the form of gravitational waves, and those waves, after traveling through space for nearly 2 billion years, they reached us, and then they were detected. Yes.
Okay,
Next.
sir. Uh,
Yes.
Yeah. So Santosh Kulte sir has asked the question, why Jupiter could not become star?
See, that happened due to the changes which took place, or the events which took place at the time of formation of our solar system. First four planets, Mercury, then Venus, Earth, and Mars. These are called as terrestrial planets, completely solid planets. But Jupiter, Saturn, Uranus, Neptune, those are not completely terrestrial. So scientists are still studying as to how a solar system is formed. Not only our solar system, but any other solar system in general is formed, or planetary system, let us say. So still
Right.
that research is going on, and I don't think that there is a definite reason which scientists have found out about formation of Jupiter.
Yeah, sir. I'll just take two more questions, sir.
Yeah.
One question by Prashant Vak sir. How does a pulsar rotate so rapidly? If it gives out pulses with accurate time periods, then it must be having some constant energy source to maintain its motion, or else it shall eventually slow down. But it does not seem to slow down. So, I just wanted to like you, sir. How energy source will be what? What about energy source for this?
See, as far as rotation is concerned, if we observe any object in the universe, it is moving. So motion is the basic thing that we observe in the universe. So the
Okay.
basic rotation of the pulsar or neutron star is not anything unusual thing. What is unusual is that it is emitting pulses. So why these pulses are generated? So to understand that, let us see what is inside a neutron star. As the name is suggesting, that object is made completely of neutrons. Now this is an extraordinary thing which we never come across in science, and that particular structure is found over there. But it is an object which is totally made up of neutron. Now when it is rotating with tremendous speed, some neutrons on the surface of this pulsar, they get converted into proton and electron. And pulsar is emitting those electrons. And these electrons are accelerated. As we know that a charged particle, when accelerated, gives out electromagnetic radiation. So that is how electromagnetic radiation is given out by a pulsar. So
Okay.
the reason for getting the waves from the pulsar lies in this phenomenon.
Right, sir. Sir, there is question from one of our past chairman, Kishorji Vyas, uh, where in our Vedas and Puranas we can find this deep knowledge about astronomy. Does this tallies with modern science?
See, actually, we know about Aryabhat, Varami, Pranad. So all these scientists have contributed a lot uh, to science and to astronomy. But we cannot say that everything was there in our Puranas and Vedas. So that much answer I can give.
Okay, sir. One question from Gunjan Harsole. What is the difference between dark matter and dark energy?
See, matter and energy, as we know, matter is something which occupies space, which has got mass, while dark energy is radiation. Energy is radiation. So now, still, we don't have complete knowledge about dark energy and dark matter, but the basic difference is what I have told you.
Okay. Makran Malpure sir has asked one question. How much time it would take for satellite moving with speed of light to reach at the edge of universe?
I have told you that according to the present knowledge, the age of the universe is some 93 billion light years away from us. So those many years will be required.
Right, sir. Just a minute, sir. I'm just checking some more questions are there.
But by the time it travels up to that boundary, the universe would have expanded further. So it will go on and on. Because expansion of the universe is continuously taking place.
Great. Sir, Advait J has asked one of the question, why Uranus is tilted in 90 degrees?
See, that has happened due to various phenomena those have taken place in the formation of our solar system. See, this angular motion, that is rotation or revolution, it has been there due to the basic principle in physics, that is conservation of angular momentum. And because of that, all these planets have got angular momentum, maybe rotational or revolution. So that is what we can say about Uranus.
Right, sir. Okay, sir. Chandrakala Sononi ma'am has asked one of the question, what is God particle?
First, let me tell you that God particle is a wrong description of that particle, because there is nothing related to God. There is no godliness in the particle which was detected. See, that was a very interesting experiment and fundamental experiment which was going on in the Large Hadron Collider. See, when we say that an atom is made up of say neutrons, protons, and electrons, then question is, what is proton made up of? So then scientists found out that it is made up of quarks. Then question was, is quark made up of anything? The answer was no, because quark was a fundamental particle. Then question was raised that why at all quark has got mass? So this is the most fundamental question which anybody can ask, that what is meant by mass? Why at all there is mass to even to an elementary particle? So even Newton could not, or rather did not answer this question. He talked much about mass and inertia, but Newton did not do any research on why there is mass. So there was a scientist named Higgs, British scientist. And in 1964, he predicted that there must be a particle which was termed as Higgs boson. Boson is a type of particle. So he said that there must be a particle which is responsible for the mass of any particle. So he predicted this in 1964, and after 48 years, in 2012, Higgs boson was detected in the laboratory.
Right, sir. There are so many questions, but I'm now just taking last two questions asked by Gaurav Mahajan. Sir, why do we call Uranus as sideway planet?
It is called a sideway because its axis is tilted by 89 degrees.
Okay.
That is why it is called as sideways.
Okay, sir. The last question of the gathering asked by Deepali Dhake ma'am, why why matter waves always travels faster than light?
No, matter waves are not. See, basically, the matter wave has got another meaning, which is given by de Broglie. So those are not traveling faster than light waves. Gravitational waves, they are traveling with speed of light.
Right, sir. So thank you so much, sir, for answering all the queries. I'm sorry if some of the queries are missed from my end. So now I request Sagar Bhausar, sir, to please give vote of thanks. Sir, can you please stop your screen sharing?
Yeah.
I request Sagar Bhausar, sir, to please give takeaway message of today's session and please give vote of thanks of the session.
Good evening, everyone. I'm honored and lucky to have the opportunity to give a takeaway message and vote of thanks on this special occasion. It was really an excellent session by Mr. Dr. Girish Pimple, sir, as he has very good knowledge on this subject. He really took us for universal tour in this online session. His session was really very informative and with the help of photos, computer animation, videos, and other videos, real-time videos of various stars, satellites, planets, and Earth. So I hope everyone enjoyed voyage of space without any visa, passport, and spaceship. The way in which he explained this subject was extraordinary. Thanks a lot, respected Dr. Pimpe sir, for excellent session. I would like to thank respected Korode sir, Sane sir, and Puranik sir for their valuable guidance, suggestions to make this event successful. I would like to thank team of SNGV College Chandwad for their valuable support all the time. I must not forget to thanks participant of Pan India, the organizing teams, our mentor Karkanis sir and management committee member and backend teams who contributed to organizing this session very successfully. Finally, I again want to thank present chairman, past chairman, trustees, all patrol members and all participants for attending this webinar on this holiday festival. I would like to thank you all again for making this event a great success. Thank you, Professor.
Great.
Thank you.
So
Thank you very much. Thank you very much.
yeah, hello, sir. Our principal have given one of the very good note today that our principal, Dr. M.D. Kokate sir, have given very good note today about this particular session. It was really great tour that you have given, virtual tour. We all are seated at home, but you have given that great tour. So with this,
Thank you very much.
Yes, sir. I request everyone, we have given you the feedback form on the chat window of Zoom as well as YouTube Live. I'll be happy if you just simply click and simply give the feedback of this particular session. Upon completing this form, you will get your e-generated certificate. So I request everyone to please fill up that particular form. I once again thankful to everyone, especially our resource person who have given wonderful tour today of universe, and special thanks to Puranik sir for this kind of giving us this particular opportunity to host this session under CSI Nashik chapter and SNJB's KB Jain College of Engineering Chandwad. With this note, I once again wish everyone a very very happy गणेश चतुर्थी. गणेश आज खूप चांगला कार्यक्रम आपल्यासाठी घेऊन आलेला आहे, त्यामुळे आपण सगळ्यांनी आनंद व्यक्त केलेलाच आहे या कार्यक्रमाचा. Sir, I would like to say that very good remark which is given, appreciation remark is given by many of our member at Zoom chat window also, even on YouTube chat window also. As per Jain Savansari, today is Jain Savansari, so I again once again say Kamat Khamna to all members and once again give you the wishes of Ganesh Chaturthi. So with the permission of higher authority, can I ask technical team to end this session? Karode sir, Kokate sir. Okay. Thank you, sir.
Thank you.
Thank you.
Thanks a lot.
Thank you. Thanks a lot.
Good session.
Thank you so much. Wonderful.